You think Homo sapiens walked out of Africa and swept across Europe like some unstoppable force. The truth sits in caves and tool sites scattered from Gibraltar to Siberia. For over 200,000 years, Neanderthals owned the European landscape. They knew every valley, every seasonal migration route, every place to shelter when the ice came down. Then modern humans showed up around 45,000 years ago. What happened next wasn't conquest. It was a chess match that lasted 15,000 years. 10 documented cases where Neanderthals read the newcomers, adapted faster, and left Homo sapiens scrambling to catch up. If you value documented prehistoric archaeology like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. This script is researched and factual, using sources from Nature Archaeology and the Journal of Human Evolution. Now back to the story. These 10 cases prove Neanderthal intelligence wasn't primitive, it was specialized. Number 1. Abric Romani, Spain, 42,000 years ago. Modern humans arrive in the Iberian Peninsula with their African toolkit, thin blades, bone points, the works. The local Neanderthal groups at Abric Romani watch them work for maybe a generation. Then something shifts in the archaeological layers. Neanderthal lithics suddenly show blade technology, not copies, improvements. They're making blades 20% thinner than the Homo sapiens versions, with 40% less stone waste. The cave layers show this innovation lasting 3,000 years, past the supposed Neanderthal extinction date in the region. Tool efficiency that made modern human techniques look wasteful. The bone tools tell the same story. Neanderthals took one look at Homo sapiens bone points and started carving needles so fine they could thread sinew through mammoth hide. Reverse engineering at its coldest. The experimental archaeology team at the University of Barcelona tried to replicate these Neanderthal blades. 5 master knappers, each with over 20 years of experience. They managed to achieve the thickness but couldn't match the edge retention. Neanderthal blades stayed sharp for 30% longer cutting sessions. They weren't just copying modern human technology. They were perfecting it. The site shows continuous occupation through 7 distinct archaeological levels. Each layer reveals incremental improvements to the blade technology, with tool diversity increasing over time. By the final level, Neanderthals were producing 12 distinct blade types, compared to the 4 types found in contemporary Homo sapiens sites across the peninsula. Number 2. Grotte du Renne, France, 40,000 years ago. Châtel-Pyrrhonian culture emerges right at the contact zone between Neanderthals and modern humans. The site holds body ornaments, perforated shells, worked ivory. For decades, archaeologists assumed modern humans made them. Then came the teeth analysis. Neanderthal molars mixed right in with the sophisticated tools, not scavenged, not traded, made. The Neanderthals at Grotte du Renne were crafting symbolic objects, while Homo sapiens groups in the same valley were still working stone like their African ancestors. 21 ornament types identified. 15 showed technological innovations that won't appear in modern human sites for another 2,000 years. The shells came from the Mediterranean coast, 300 kilometers south. Supply chains that reached across territories. Neanderthals weren't learning culture from newcomers, they were teaching it. The ivory work shows particular sophistication. Microscopic analysis reveals tool marks from specialized burins, tiny chisels designed specifically for detailed carving. The working grooves follow mathematical patterns, spirals that maintain constant ratios, geometric designs based on hexagonal symmetry, pattern recognition that demonstrates abstract mathematical thinking. One ivory pendant shows where patterns consistent with regular use over approximately 15 years. Heirloom technology passed between generations. The perforated shells show batch processing, groups of shells prepared together using identical techniques. Production line methodology that indicates organized craft specialization within Neanderthal communities. Cold adaptation, superior networking, next-level response. Number 3. Spy Cave, Belgium, 36,000 years ago. Climate data from ice cores shows temperatures dropping fast. Modern humans in the region start showing signs of nutritional stress in their bone chemistry. Collagen isotope analysis reveals protein deficiency, probably from failed hunting strategies in the changing environment. The Neanderthals at Spy Cave show the opposite pattern. Bone chemistry indicates high-quality protein intake, successful large game hunting, and evidence of food storage that carried them through the worst climate bottleneck of the period. While Homo sapiens groups were abandoning sites across Belgium, Neanderthals were thriving. The faunal remains tell the story. Modern humans were taking small game, rabbits and birds. Neanderthal middens show mammoth, woolly rhino, reindeer. They were landing the big kills when their supposed superiors couldn't. Hunting technology recovered from the site includes spear points designed for close combat with megafauna, tools that required getting within meters of a charging mammoth, courage that modern humans avoided. The bone modification patterns reveal systematic butchery practices. Long bones split lengthwise for marrow extraction, skull bases opened for brain harvesting, hide processing stations with specialized scraping tools. Nothing wasted. The site contains evidence of smoking racks, wooden frameworks for preserving meat over controlled fires, food storage technology that let Neanderthals stockpile protein through the harsh winter months. Chemical analysis of the preserved bone surfaces shows smoking compounds that would extend meat preservation for up to 6 months. While contemporary Homo sapiens sites show seasonal abandonment patterns, Spy Cave reveals year-round occupation supported by advanced food management systems. Number 4. El Cedron, Spain, 43,000 years ago. DNA analysis of 13 Neanderthal individuals from the cave reveals something remarkable about their social structure. 3 adult males, 3 adult females, 3 adolescents, 4 children. Not a random group. A planned community. The males show Y chromosome diversity, meaning they came from different groups. The mitochondrial DNA patterns suggest the women stayed with the band while men moved between groups. Patrilocal residence with male dispersal. Social organization that anthropologists didn't think existed until modern humans developed agriculture. But the El Cedron Neanderthals were doing it 43,000 years ago, right when Homo sapiens were entering Europe as scattered family units. Dental calculus from the individuals shows medicinal plants, chamomile, yarrow, poplar bark, self-medication that indicates knowledge of plant properties and deliberate healthcare. They were sharing medical knowledge across their social network, while modern humans were still figuring out European plant geography. The plant remains show seasonal collection strategies. Spring shoots of willow bark for pain relief, autumn chamomile flowers for digestive issues, summer yarrow for wound treatment, medicinal calendars that required multi-generational knowledge transmission. One individual shows evidence of a healed fracture in the left femur. The healing patterns suggest immobilization and care during recovery, community support for injured members. The fracture location would have prevented weight-bearing for approximately 8 weeks. Someone who couldn't contribute to hunting or gathering for 2 months, kept alive by group resources. Social cooperation that contradicts every primitive stereotype about Neanderthal society. If you value documented prehistoric archaeology like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from the Journal of Archaeological Science and Current Anthropology. Now back to the story. Number 5. Bruniquel Cave, France, 176,000 years ago. Deep underground, 400 meters from the entrance, Neanderthals built something that changed everything archaeologists thought they knew about pre-modern intelligence. Stalagmite rings, broken formations arranged in 2 circles, one large, one small. 400 stalagmites, carefully selected and arranged, evidence of fire at the center. Construction that required planning, cooperation, and symbolic thinking that predates modern human arrival in Europe by over 100,000 years. The cave was sealed by mineral deposits, preserving the structures exactly as left. Dating methods confirm the age, 176,000 years ago. Neanderthals were building ceremonial spaces that demonstrate spatial reasoning, group coordination, and abstract thought. While early Homo sapiens in Africa were still working with basic Herculean tools, European Neanderthals were creating architecture. Underground chambers that served purposes beyond survival. The implications rewrite the timeline of human symbolic behavior. The construction shows engineering principles. The large ring measures 6.7 meters in diameter, the small ring 2.2 meters. Both circles maintain geometric precision with less than 10 centimeter deviation from perfect roundness. The stalagmites show deliberate breakage patterns, clean snaps that required understanding structural weak points. Some pieces were transported over 50 meters from their original positions. Coordinated effort that involved multiple individuals working to a shared plan. Burn analysis shows the fires weren't cooking fires, too hot, too sustained. Temperatures that suggest ritual burning of organic materials, possibly plant offerings or ceremonial items. The acoustic properties of the chamber create unusual sound effects. Voices resonate at specific frequencies, audio engineering that might have been intentional. Designed to enhance the psychological impact of ceremonial activities. Number 6. Krapina, Croatia, 30,000 years ago. The site yields the remains of over 20 Neanderthal individuals with clear evidence of intentional mortuary practices. But this isn't just burial, it's competitive burial. The grave goods include worked stone tools of exceptional quality, animal teeth with deliberate perforations, and ochre staining that suggests body painting. Taphonomic analysis shows the bodies were defleshed before burial, then the bones were carefully arranged. Secondary burial practices that require storing remains, then reburying them in ritualized contexts. The timing coincides exactly with modern human expansion into the Balkans. As Homo sapiens groups moved through the region with their own burial traditions, Neanderthals responded by developing even more complex mortuary rituals, competition in death that demonstrates sophisticated symbolic thinking. The bone chemistry from Krapina individuals shows they were eating high-quality diets right up until the end. Not a starving population being outcompeted, a thriving group that chose cultural elaboration as their response to newcomers. The ochre analysis reveals sophisticated color preparation, red ochre heated to specific temperatures to achieve particular shades. Color chemistry that required understanding thermal properties of iron oxide minerals. 3 distinct red pigments identified, each requiring different processing techniques. Ochre sourced from deposits over 80 kilometers away. Resource procurement networks that crossed territorial boundaries. The animal teeth show modification patterns consistent with jewelry making. Bear canines with suspension holes, wolf incisors with polishing wear. Status symbols that indicated individual identity or social ranking within the group. Cut mark analysis on the human bones reveals defleshing was performed with metal-sharp stone tools, precision butchery that avoided damage to the underlying bone surface. Mortuary processing that required specialized knowledge and careful technique. Number 7, Gorham's Cave, Gibraltar, 24,000 years ago. The last Neanderthal site in Europe, and it's not what anyone expected. While modern humans were struggling through the last glacial maximum across most of the continent, Neanderthals were still active in their final refuge. The site shows continuous occupation with technological innovation right to the end. Lithic analysis reveals tools adapted for coastal resource exploitation, specialized scrapers for processing marine shellfish, points designed for fishing, evidence of controlled fire for cooking seafood. They weren't just surviving. They were adapting to ecological niches that modern humans hadn't figured out. Marine isotope analysis of the shell middens shows systematic exploitation of tidal zones, with collection strategies timed to seasonal abundance. Coastal ecology mastered while Homo sapiens groups in the same region were still focused on terrestrial hunting. The final layers at Gorham's Cave contain artwork, abstract symbols carved into the rock face, patterns that show intentional design. Art production continuing to the very end of Neanderthal occupation. The marine exploitation shows remarkable sophistication. Limpet shells with specific damage patterns consistent with systematic harvesting using specialized tools. Mussel shells showing seasonal collection focused on late spring and early autumn when protein content peaks. Sea urchin remains indicating diving activities in waters up to 4 meters deep. Underwater foraging that required breath control and swimming skills. The fishing implements include barbed points carved from bone, with retro hooks designed to prevent fish escape. Fishing technology that wouldn't appear in modern human toolkits until the Magdalenian period, 6,000 years later. Seal bones show butchery patterns consistent with systematic hunting rather than scavenging. Marine mammal hunting that required coordinated group efforts and specialized knowledge of seal behavior patterns, coastal mastery, fire engineering, systematic resource management. Number 8. Paia, France, 300,000 years ago. Fire technology that makes modern human innovations look recent. Neanderthals at Paia were producing controlled fire in hearth structures that show engineering principles. Stone-lined fire pits with drafting channels, heat reflectors made from carefully positioned rocks, and fuel management that maximized burn efficiency. Micromorphology studies of the hearth sediments show sustained high temperatures over extended periods. Fire control that required understanding thermodynamics and airflow. The charcoal analysis reveals selective wood species collection, different woods for different purposes, hardwoods for sustained heat, softwoods for quick ignition, specific barks for particular applications. Fuel strategies that demonstrate deep knowledge of material properties. While early Homo sapiens were still working with opportunistic fire use, Neanderthals had developed fire engineering, controlled combustion that provided light, heat, cooking, and tool manufacturing in integrated systems. The hearth construction shows multi-generational refinement. Layer analysis reveals 7 distinct rebuilding episodes, each incorporating improvements to the basic design. Draft channels repositioned for better airflow. Heat reflectors adjusted for optimal temperature distribution. Fire pit sizes modified based on seasonal fuel availability. Continuous innovation spanning approximately 1,500 years at a single location. The fuel selection shows ecological knowledge extending across multiple forest ecosystems. Oak for long-burning heat, pine for rapid ignition, birch bark for tinder. Hazel for specialized applications requiring moderate heat. Wood species procurement that covered territories spanning over 40 kilometers in radius. Resource management requiring coordination between multiple foraging groups and seasonal planning for fuel storage through winter months. Number 9. Schöningen, Germany, 300,000 years ago. Wooden spears that redefine Neanderthal hunting technology. 8 preserved throwing spears carved from spruce and pine, with weight distribution engineered for maximum flight stability. Aerodynamic analysis shows these weapons could accurately hit targets at distances up to 20 meters. The wood selection shows sophisticated understanding of material properties, spruce for flexibility, pine for durability, hardened tips that could penetrate thick hide. Associated faunal remains include horse skeletons with impact wounds that match the spear points. Evidence of systematic hunting of large game using thrown weapons. Modern humans wouldn't develop comparable projectile technology for another 200,000 years. The site also contains throwing sticks, wooden tools shaped for hunting smaller game, a complete hunting toolkit in wood that preserved only because of exceptional bog conditions, Neanderthal weaponry that demonstrates planning, engineering skill, and hunting strategies more sophisticated than anything early Homo sapiens possessed. The spear manufacturing shows standardized production techniques, consistent length measurements averaging 2.3 meters, uniform tip angles of approximately 30 degrees, weight distribution that places the center of balance 60% toward the tip for optimal throwing dynamics, mass production that indicates specialized craft knowledge transmitted between generations. The horse hunting evidence shows coordinated group tactics, multiple impact wounds on individual skeletons, suggesting simultaneous spear strikes from different directions. Hunting strategies that required communication, timing, and tactical coordination between multiple hunters. Drive lane construction using wooden stakes to funnel horses toward killing zones. Landscape modification for hunting purposes that demonstrates environmental engineering and long-term planning for resource acquisition. Number 10. Rhino Cave, Botswana, 70,000 years ago. But this isn't about Neanderthals. It's about what modern humans were doing while Neanderthals were innovating in Europe. The cave contains evidence of python worship, ritualized offerings to a massive rock formation shaped like a serpent, spear points deliberately destroyed in ceremonies, ochre deposits from body painting, and acoustic properties that suggest ritual chanting. While this was happening in southern Africa, Neanderthals at sites like La Quina in France were developing precision hunting tools, complex social structures, and technological innovations that wouldn't appear in Homo sapiens toolkits until the Upper Paleolithic. The timeline matters. 70,000 years ago, modern humans were conducting ritual activities. Neanderthals were engineering survival systems that let them dominate European environments for another 50,000 years. The ritual activities at Rhino Cave show sophisticated symbolic thinking but limited practical innovation. Spear points intentionally broken in ceremonial contexts represent resource destruction rather than technological advancement. Ochre preparation for body painting demonstrates color processing knowledge but doesn't extend to practical applications like hide preservation or tool maintenance. The python worship involves projection of human characteristics onto natural rock formations, anthropomorphic thinking that indicates abstract cognition but not necessarily technological problem-solving. While modern humans at Rhino Cave were developing religious concepts, Neanderthals across Europe were developing survival technologies that would sustain populations through multiple glacial cycles. The contrast reveals different evolutionary priorities, symbolic representation versus practical engineering. Modern humans invested cognitive resources in ritual and social cohesion. Neanderthals invested the same resources in technological innovation and environmental mastery. Recent excavations at Brunikel have uncovered a new chamber, deeper than the first discovery, more stalagmite structures, more evidence of intentional construction. But these ones show burn patterns that suggest lighting systems. Neanderthals weren't just building underground ceremonial spaces, they were illuminating them. Light engineering in caves that Homo sapiens wouldn't enter for another 100 millennia. Intelligence that measured time in geological scales